When we look at Saturn, it's easy to think of its rings as a single solid band wrapped neatly around the planet. But the reality is far more complex, far more dynamic, and far more surprising than most people imagine. Saturn's rings are not a disk of solid material. They're an enormous, delicate system made of countless particles, anything from microscopic grains of ice to objects the size of mountains. If you could scoop up a handful from the rings, you'd find almost pure water ice, mixed with a thin layer of dust and rock. From afar, the rings appear smooth. Up close, they behave more like a constantly shifting river. Every particle orbits Saturn at its own speed, obeying the same gravitational rules that shape moons and planets. The inner particles race around faster while the outer particles drift more slowly. This constant motion prevents the rings from collapsing into a single sheet. The gaps you see in Saturn's rings aren't empty by accident. They're carved by gravitational interactions, some with Saturn's moons, others with the particles inside the rings themselves. A moon may shepherd particles into narrow bands, maintaining sharp edges as if tidying up the ring structure. Other gaps appear when orbital resonances cause particles to become unstable, clearing out entire regions over millions of years. What makes the rings even more remarkable is their thinness. Although the ring system spans more than 280,000 kilometers across, its thickness is usually no more than about 10 meters. So thin that if Saturn were the size of a basketball, the rings would be thinner than a sheet of paper. But one of the biggest mysteries is their age. For decades, scientists debated whether Saturn's rings were ancient leftovers from the birth of the solar system or a much more recent formation. Today, evidence suggests they may be surprisingly young, perhaps only 100 million years old, formed from a shattered moon or a captured comet torn apart by Saturn's gravity. In cosmic terms, that would make the rings younger than the dinosaurs on Earth. Yet the rings may not last forever. Tiny ice grains fall slowly toward Saturn, pulled inward by gravity and dragged down by the planet's magnetic field. This ring rain means the rings are slowly disappearing, potentially vanishing entirely within a few hundred million years. We live at a privileged moment, able to witness a structure that might be only temporary on the cosmic timeline Cassini. The spacecraft that explored Saturn for more than a decade revealed details no telescope on Earth could capture. The sculpted waves caused by moonlets, the braided and twisted edges, the shadows cast by vertical ripples, and the stunning complexity of the icy material. What looked simple from a distance turned out to be one of the most intricate gravitational systems in the solar system. Saturn's rings are not just beautiful, they are a laboratory for understanding how planets, moons, and even planetary systems form and evolve. They show us how gravity organizes matter, how collisions create structure, and how complexity emerges from simple physical rules. And as they slowly fade away, we're reminded that even the most majestic features in our solar system are temporary. For now, though, Saturn's rings remain one of the most extraordinary sights we can witness. A frozen symphony of ice, motion, and light circling silently around a gas giant.